Look around, and the world seems like a mess of unpredictable motion. A spiraling pass down a field, cars rushing down a highway, leaves tumbling in the wind. It all looks completely random. Zoom out, and you see movement on a massive scale. A million-pound spacecraft tearing through the atmosphere atop a pillar of fire. Instinctively, it feels like these two events, a casually tossed ball and the highly engineered launch of a rocket, operate entirely independent of one another. They appear to require different physical rules. But underneath the apparent randomness, there is strict order. Every single movement in the universe is chained to an escapable logic governed by Isaac Newton's 3 laws of motion. The first link in that chain is inertia. The baseline reality of the physical universe is that movement doesn't just happen on its own. Objects prefer to stay exactly as they are. If a ball is sitting quietly on the grass, it will stay there forever. It resists moving until an outside force, like your foot, disrupts it. That same resistance applies to motion. Take away the friction of the grass and the drag of the air. If you put that rolling ball in the pitch-black vacuum of space, it won't stop, because no external force gets in its way. That is Newton's first law. An object's state, whether entirely still or infinitely cruising, is permanent until something physically forces it to change. Curious. So if objects resist change, how do we know exactly how much effort it takes to force them out of their current state? This formula provides the answer. Newton's second law. Force equals mass times acceleration. If you apply a standard push to an object with very little mass, say an empty bicycle, that small mass translates your push into a high rate of acceleration. The bike speeds up almost instantly. Now apply that exact same push to a heavy truck. The mass is enormous, so the resulting acceleration is practically invisible. The truck barely twitches. Mass acts as a universal tax on movement. To achieve the same burst of speed with a heavy object as a light one, you have to pay a much higher premium in force. Applying that force triggers the final rule. The universe demands absolute physical equilibrium in every interaction. Newton's third law dictates that forces exist in pairs. Any action you take produces a reaction of the same magnitude, traveling in the opposite direction. Imagine you are standing on a small boat and decide to jump toward the dock. To get your body moving, your legs have to exert immense downward force. You literally shove the deck backward. That is the action. The reaction is the boat absorbing that downward drive and transferring it right back into your body, firing you upward into the air. You cannot touch, hit, or push anything in this universe without it pushing you back exactly as hard. These 3 rules define every interaction. Objects stay put until forced. Heavy things demand an immense push, and every shove pairs up with an equal push backward. Together, these principles allow us to predict the invisible mechanics behind every movement we see, from a falling leaf to the trajectory of a star. Let's apply this to one final scenario. You strap on a pair of smooth roller skates, roll up to a solid brick wall, and shove hard against the masonry. The moment your hands exert pressure on the bricks, you instantly shoot backward, rolling away from the wall. The question is, which specific law explains why the wall is the thing that sends you moving in the opposite direction? Share your reasoning in the comments below.